By the end of this short geometry nodes tutorial, you'll be able to track objects in 3D space using only geometry nodes. Let's get started. All right, so the first thing that you'll want to do is download the starter file from my Gumroad. It's a free download, so click the link in the description and you can follow along easily. What we want to do is have it so that this fighter jet will always point to these turrets and vice versa, that the turrets will always point to the fighter jet. And we can get a quick sneak peek what that looks like by adding a constraint, the track2 constraint. And if we specify the target being a turret, and then specify the negative y axis with the z being the up. Actually, you know what? Let me track this one in the middle. You see how it will point its local axis. So this is positive y, so now it's pointing the negative y towards this turret. And we can do this in geometry nodes pretty easily. Let's disable this constraint. So go back to looking default in the negative y axis. And to start, we'll add a geometry node setup here. All right, so to understand the math, which is super simple vector math involved, let's take a look at the Godot documentation in their vector math article. In this case, we have a tank and a robot, kind of like the fighter and a turret. And the equation is super simple. You take the robot's position, which is the target, and you subtract the tank. The tank is what wants to point to the robot. So it's the target minus yourself, or in this case, the turret minus the fighter jet. And it works really, it's just the difference. All right, so to implement that in geometry nodes, we can, first of all, we need to know two locations, right? The location of the fighter, location of the turret, or the target rather. So let's pull in the object info. So Shift A, object info, and we have ourself, the owner of this geometry node modifier. So the self object. And then we also have the target, right? And we want to make this so that it's reusable. So we will specify an input as this group input here. And you can see here in the modifier stack, we have this blank object now, and we can tweak the parameters, what this looks like by saying, double clicking here. If you don't have this panel, press N to pull that up and make sure you're in the group tab here. And then you can type target, and that changes in the group input here and in the geometry node modifier here. So now you can specify which object you want to target. And right now, obviously it's not pointing towards it, so we need to do that vector math in geometry nodes. So we'll pull in a vector math node, put in between the, let's actually label this. Let's select these two nodes, press Command J, Control J, and F2. This is owner, like the jet's owner. And then the same thing, Command J, F2, this is the target. So then Godot documentation in the vector math article, it said target minus the owner. Remember, it was the turret minus the tank, or at least the robot minus the tank. So in this case, it's the turret's location, it's a vector, and we've got the self, the tank. So let's see, maybe I swap these around just to kind of match target and definitely subtract those two. So that gives us the vector that will point from the jet to the turret. It's really just the difference between this point and this point in 3D space. So whatever that vector is, we want to align our fighter jet to it. And align being the keyword, we can Shift A, pull out an align Euler to vector. And ultimately, when we do perform this alignment, we'll want to transform the geometry. So if we plug this vector, this is the result vector that we want to align to, plug it into the vector input here. This gives us the rotation on X, Y, and Z. Thinking back to the constraint, or the track2 constraint, we want the Y-axis the turret. In this case, it's going to, by default, this positive Y will point this jet toward the turret, the back. It's pointing positive Y towards the turret, which is the reason for it pointing backwards. So what we can do then is simply duplicate Shift-D the geometry or the vector math node, and then we'll scale it by -1, and that will reverse it. Now it is working in that we've got the jet pointing toward the turret, but it's definitely not as good as the track to constraint was. In fact, if we grab this, you can see how it flips around as you spin around the turret. Whereas if we turn off the geometry node, go back to the track to, it stays nice and flat like that. So we want to enhance our geometry node setup to copy this behavior. And we can do that by going back to the geometry node, activating it again. Remember, the trick had this additional up axis that's specified, and by default it's positive Z in world space. So we can simply add that additional feature to our setup by Shift-D on Euler to vector. And then if we specify the Z axis, now it's looking better, although it's not quite pointing to it. So if we maybe change the pivot to Y, there you go. And that will make it so that if we try to point the Z-axis up, it will rotate to flatten itself out on the Z-axis. If we turn this factor off, you can see how it goes back to being banked like that. And if we turn the factor on, you can see that it's rotating on the Y-axis to the point where it's pointing as straight up on the Z-axis as possible. If that was a little confusing, feel free to play around with some of these factors. You can see what the factor looks like when it's off, how it simply just points around and aligns on that vector. And you can see the vector right there, actually, this blue dotted line, which is that's actually the track to constraint. The track to constraint shows that line. So if we get rid of that, you can see it go away. But that's essentially the vector that it's aligning to when we change this factor to 1. And then when we change this additional alignment factor up, it rotates on the Y-axis. And now that is as good as the track to constraint. If you grab Shift-Z, you can see that it stays flat, just like the constraint was doing as well. So let's clear off the track to constraint, go back to geonodes modifier. And now with this set up properly for the fighter jet, we can do the same thing for the turret. All we have to do is add a modifier here, select the same track to, and we'll set the target to be, right now it's pointing to 0, 0. Set the target to be the fighter jet, and then click each of these turrets and click the one that has the geometry node on it last, and then copy to selected here. Now they are all facing the fighter jet. We move around here, see how they all easily track with just a few geometry nodes and some super basic vector math. All right, so if you enjoyed the video, be sure to like and subscribe. We got more geometry nodes videos coming up on the horizon. Super fun to play with these and kind of play with vector math, game engine concepts, that kind of thing. Be sure to subscribe, and we'll see you in the next video.